Welcome everyone to the class of marketing research and analysis. In the last session we had discussed about a very important grouping method which was called the factor analysis, and thereafter we discussed about another grouping method which was called the cluster analysis, right. So, factor and cluster were two important techniques that were used to differentiate or to create groups or clusters, so that respondents could be categorized or easily brought into different groups, right, clusters, so that each cluster had its own characteristic different from the other cluster. Okay. So, that was a very important way of classification which we used to classify the cases, the respondents, the products, anything you can say, right. But today we will talk about a situation where a marketer is faced with a very important observation. Let us say there is a bank which has to give a loan. Okay. Now the question is, the bank has to decide whether the client is a worthy client or not, right. So, in such a situation, if it is not a worthy client and by chance the bank offers a loan to the client, then the bank will lose its money, right. Maybe the like many big corporate houses today are siphoning off the bank's money and not paying, staying in London or somewhere. So, they are not paying the bank's money and the banks are completely getting into losses, which has increased the non-performing assets of the banks. So, so it has become very critical that the bank should learn whether they should give a loan to this client or not. Similarly, a credit card company wants to also find out whether they should give a credit card to the client or not, right. Many other examples could be given. For example, whether should I take a candidate to my course or should I not take a candidate to my course, right. Some other cases where you want to know whether a particular person, let us say, falls into very let us say as per his religious affiliations into a highly religious, moderately religious or not religious at all kind of a group, right. So, whatever the condition is, here if you see all your decisions are basically depending upon variables which are categorical in nature, right. So, if my dependent variables are categorical in nature, that means I can only say whether it is, let us say for example, the loan should be given, yes, 1, or loan should not be given, a 0, right. So, my decision is based on 0 and 1, right, could be 0, 1, 2 in some cases, right. For example, not given, yes, surely given, moderate, I do not know, can be given or not given, can't say kind of a situation, right. Somebody is highly religious, somebody is moderately religious, somebody is let us say not religious, however you want to break it up. So, the question emerges here is this, obviously I think you have understood how important this is, right. So, the researcher or the bank or the marketer wants to divide or separate the clients on basis of certain variables, right. So, the question is how will he do this? So, to do this such kind of a to take such kind of a decision, we use two basic techniques. One is called discriminant analysis. The other is a form of regression only, which is called logistic regression. Okay. So, logistic regression and discriminant analysis are two types of techniques which are used very largely, so that the decision maker can take a decision which is based on a categorical level, right, or the decision is like a categorical variable, right, but his decision is based on certain independent variables which are all continuous in nature, So, as a result, the researcher has to So, what is the way how the researcher is going to work on such a problem, right. To do this, as I explained, we do have discriminant analysis and logistic regression. Before I go further, what is the basic difference? Although logistic regression is a special case of regression which I will be taking up in another maybe session. Today I will be talking about the discriminant analysis. The discriminant analysis and the logistic regression, the difference, although we today have multiple multinomial logistic also, but the advantage of discriminant is that discriminant is little more powerful than the logistic, but on the other hand discriminant is also highly susceptible to certain assumptions, right. For example, the data should be normal in nature, right. So, there are certain which I will be telling you in the session, where the researcher has to understand that discriminant analysis and logistic regression, although they do the same thing, same job, but discriminant is little more powerful in comparison to logistic, because logistics is generally done with 0 and 1 case, yes and no case, but discriminant analysis can take up more than 2, 3, 4 also categories, but too larger number of categories also is not very advisable. Okay. So, let us see. Let us take a first case. We wish to predict group membership for a number of subjects from a set of predictor variables. That means predictor variables are my independent variables. So, with the help of these independent variables, I want to predict group membership, whether let us say Mr. X will fall into the category of loan paying category, or he will not fall into the category of loan paying category. So, whether he is a loan payer or not payer, for example. The criterion variable is the object of classification, right. So, this is always a categorical variable, as I have mentioned, if you can see. So, it is always a categorical variable, 0, no, 1, yes, right, or could be 2, whatever. Let us take this case example. We want to know whether somebody has lung cancer or not, right. So, there are two possible outcomes, yes, he has a lung cancer, or no, he does not have a lung cancer. So, the possible predictor variables in this case which I have taken is, if you can see, is like how did I take this possible predictor variables? That is simple, from your maybe past experience, earlier research that has been done in this area of study, or maybe your own understanding. So, the possible predictor variables, for example, in this case are number of cigarettes smoked per day. So, how many cigarettes the person is smoking per day is one of the important predictor variables. Second is, what is the coughing frequency, how many times is he coughing, right. So, that would indicate whether he has got a lung cancer or not, right. The intensity of the coughing. So, is the coughing very highly intensive? You can categorize, maybe you can give a score to that, maybe in a score of maybe 1 to 7 or 1 to 5, like in a Likert scale or something, and they are saying yes, well this is what he is doing. Or if you can measure the maybe the sound that is making, the decibel of the sound, that also could be an indicator, I do not know, you can take any way, right. So, to measure this, whether he is having a lung cancer or not, we can use this variables, the predictor variables, to decide whether the person has got lung cancer or not. But the question is, how is this going to help us? Now, before this, let me tell you, with a simple common sense we can all understand that a person can only, you can only predict the future when you have a past in knowledge. That means, I should be having certain data, for example, of people who had lung cancer, and how was their smoking habit, how was their coughing frequency, and how was their intensity. If I knew this earlier, then I could possibly create an equation and find out whether if a new patient is coming, by looking at these variables, the scores or the coefficients of these variables like coughing frequency, intensity and cigarettes, I can maybe predict well, this man is maybe possibly a patient of lung cancer or he is not, right. Okay. So, some of the basics, if you look at as it says, used to predict group membership from a set of continuous predictors, right, that is what we have discussed. Now the beauty is that if you remember, another technique which we had discussed was called MANOVA, right, an extension of ANOVA. Now MANOVA, if you remember, what were we doing in MANOVA? We were basically trying to understand how groups are behaving, right, when you have multiple dependent variables and multiple independent variables, let us say, or if not multiple independent variables, at least one, but multiple dependent variables. So when you had D1, D2 and you had some kind of IV1, IV2, right. So the relationship that we were making, but only condition was that these were at that time the categorical variables, right, and these were the continuous variables. So if you understand, if you look at it, MANOVA is nothing but the reverse of discriminant analysis, or discriminant analysis is nothing but the reverse of MANOVA, right. So in MANOVA you have the continuous dependent variables and categorical independent variables, and in discriminant you have categorical independent variables, dependent variables, and continuous independent variables, right. So that is the difference, okay. So as it says in MANOVA, we asked if groups are significantly different on a set of linearly combined DVs. So you had linearly combined dependent variables. Now these dependent variables could have a high collinearity, could not have, it is not advisable to have a high collinearity between them. So anyway, it was helping us to predict group membership, right. So as I have written, MANOVA tests whether mean differences among groups on a combination of DVs is likely to occur by chance or would it occur every time. That means it is not a chance, right. So and you were also measuring the effect of interactions in ANOVA and MANOVA. The most important thing was you were affecting the impact of interactions. Now interactions I had already explained, that means let us say A, B are affecting C. So A is affecting C, B is affecting C, but when let us say, let us understand this way. So A, B are two variables affecting C, right. So suppose A is affecting C, that thing is not significant, B affecting C is also not significant, but however there is a possibility that A cross B is affecting C and this is significant, right. So that is what helps MANOVA and ANOVA helps us to understand, okay. So I do not want to speak too much on MANOVA now because we have already discussed these things, right. I am straight away getting into the discriminant analysis overview. So what is it, why we use it? So as you can see, it is an appropriate technique when the dependent variable is categorical and the independent variables are metric. The single dependent variable can have 2, 3 or more categories. As I said, in logistic regression we generally talk about 2 categories only, 0 and 1, right, yes or no. But in case of discriminant analysis you can have even 4 categories also, but beyond a certain number of categories when you create, it becomes complicated, it becomes a very complex model, right. So for examples I have given at the side, if you see gender, is it a male or female, heavy users versus light users, purchasers versus non-purchasers, good credit risk versus poor credit risk, right, member, is he a member or non-member, attorney, physician or professor, 3 categories, right. So the point is when you are in life coming to such a situation where you have to discriminate or you have to classify them into different categories, there it becomes very important and this tool is a very powerful tool, right. So how does the dependent variable Z is equal to credit risk now for in this case, and independent variable is, for example, this is a slight case we have taken, income, education, family size, occupation, where occupation has been measured as a dummy, right. So the dummy is also a very important case which is largely used in regression, which dummy variable regression. So dummy variable coding is a method where that means if just you take the presence or absence of a item, right, if it is present then it is 1 and wherever it is not present it is 0, as good as that, right. So by taking this can we find out any relationship? Now once we have found this relationship, then after that can I use this relationship as a predictive model in the later on stages. Okay. Now if you see, for example, this is a case. Now there are 3 groups, right, the McDonald's, the Burger King and the Wendy's. Now preference for tasty burgers is low and high, and income of people is low and high. So is there any way, is it help, this is just explaining us can it be possible that we can, these dots are nothing but the respondents. So the respondents, can they be actually segregated or clearly differentiated into different groups on basis of their income and their preference for burgers? Now well, this is just to show, right. Now the one thing that is very important you need to remember is like discriminant analysis also has a very large similarity with analysis of variance, right, as I said it is inverse. What is that? Basically it measures basically the within group variances, the within group variances divided by the total variance, right. So when you do this value is nothing but, if you see in any software or anything, it is called as Wilks lambda, okay. So this variances, right, it measures the variances. So when 2 groups, when they overlap each other, so what it means is when this within group variances W by let us say tau t is very less or is sufficiently less, then we would say that when the Wilks lambda is less in in size, that means there is a clear cut distinction between the groups, right. A higher Wilks lambda tells you that there is lot of overlap, maybe something like this, right. But if it is not, then it would something, suppose the Wilks lambda is poor, then the overlap is only very less, right. So that is what it actually explains. In this you can see there is a sizable distinction between the 3 groups, McDonald's, Burger King and Wendy's, right. So the question here is, another question that is we have taken is, on basis of purchase intention and certain variables like durability, performance and style, right. So the numbers have just skipped this side, please you have to understand, this is subject number, durability, this is the durability, and performance style, sorry I am sorry, performance x2, this is the x2 and this is the x3, all measured in a scale of 0 to 10, okay, all measured in a scale of 0 to 10. Now what it does basically, now here we calculate nothing but the discriminant score, we calculate something called the discriminant score. Now discriminant score is z is equal to a plus, right, like in a regression equation, w1 x1 plus w2 x2, it goes on, right. So once we have the discriminant score with us, it helps us to identify whether the new person would fall into which category, right. So this is a survey result for the evaluation of a new consumer product, right. Now the 2 groups are would purchase, right, and would not purchase. So the group 1 are people who would purchase the item, and the group 2 are the people who would not purchase. Now if you look at the durability, the values of what they have given, the people who would purchase, how importance they have offered to durability, what is the importance they have offered to performance, what is the durability importance they have offered to style, right. And similarly the people who are not going to purchase, what is their score, right. So the difference between the 2 group means, right, if you, this was the group mean, so this was the group mean 7.4 and this is 3.2. So the difference is given here 4.2, similarly 2.4 and 0.2, right. So this helps us, right, this helps us to create a kind of prediction, to say if this is the characteristics of the people, right, then maybe by taking incorporating these values, right, we can say if a person who is coming next, what, and we asked him what is your score that you will give on durability, performance and style. So, by taking his opinion, his score, we can predict whether this man would purchase or not purchase. Just imagine, if once you can find out whether this man would purchase or not purchase, how easy it is becoming for the marketer, right. So, this is what I was talking about. So, if you look at A and B, the two groups would purchase and would not purchase, there is a very small overlap. There is a very small overlap. So, that means if in technical terms I will say the Wills lambda, right, is a very low value, right. So, a low value means, that means the within group variances divided by the total group variances is quite low. I have explained you earlier also, within group is nothing but, you can understand in my way, I explain it as the error variances, right. Okay. Now, let us see the process. So, objectives of discriminant analysis, then the research design, assumptions, what assumptions we should have, estimation, interpretation and validation, right. So, I am not taking all, but I am taking you through the some of the only important ones. First of all, how should you approach? The most common approach that is done is, suppose you have a large number of, let us say data which is continuous in nature. So, if you have a metric scale response as it is saying, you should convert it into non-metric categories. Now, how is that? For example, let us say people with 3 income groups, let us say up to 0 to 5 lakhs, 5 lakh to 10 lakh and 10 lakh and above, let us say 3 categories are there. So, just you make it 1, 0 to 5 is 1, 5 to 10 is 2 and similarly 3. So, by doing that it becomes easier for you to convert into a categorical scale, right. Okay. And the other is the approach that we use is called a polar extreme approach, right. Polar extreme approach is something where only 2 groups are used and the middle one is excluded. So, that means it is only a 0 or 1. That means you do not have that 5 to 10 lakh group in the earlier case. So, either 0 to let us say 10 and 10 and above, okay. So, you have to calculate the discriminant Z scores, right, which I said, and then you have to then something also called a cutoff score. We develop a cutoff score. Now, once you have the cutoffs, there are few things you need to remember. So, once you have the Z scores, then after this you create you calculate the centroid or the group means. Centroid or the group means, this is important. Now, what is centroid or group means? When a large number of values you have, you try to calculate the group mean, right, of each group. Now, by having this, which is also called a centroid, if in any book you see, do not get confused. So, this centroid or group mean helps you to identify how far is a particular score from the group mean. So, if it is very far off or it is very close, that helps you to decide whether it is it will be falling into the particular group or not, okay. So, it helps in it is as I said, discriminant analysis has a very practical significance. It helps you to predict and then find out how accurately you can predict basically, okay. So, one more thing, when I am talking about group mean, centroid or thing and Z score, there is another thing which is important for you to understand, that is there is something called a cutting score. Now, cutting score or cutoff score. So, what is this cutting score or cutoff score? The cutting score or cutoff score is nothing but you have to find a value to say, see what was happening. You have created 2 groups, right. Now, the question is, if a new person is coming, you need to find out whether the person will fall into which group, whether group A or group B. Now, to fall into group A or group B, there has to be a kind of a score, if you so that If it is below, so let us say the particular cutting score, then it is in let us say group B. Let us say, I am just telling you, suppose particular value is let us say 0.5. So, if it is less than 0.5, let us say this group, if it is more than 0.5, suppose let us say this group. Okay. Now, how do you find this cutting score is a very important parameter. So, this cutting score is nothing but Z is equal to Z cutting you can say is equal to N A Z B plus N B Z A divided by N A plus N B. Now, what do I mean by this? When I am saying this Z cutting score is equal to number of samples or respondents in the group A multiplied by the centroid or the group mean, right, of group B. Similarly, number of members in the group B into the centroid or the group mean of the group A divided by the total sample size. Now, this is generally this is utilized in case of unequal groups. This is used in case of unequal groups, when two groups do not have an equal number of respondents or equal size, right. However, but if you have equal, let us say, group size, then it will become simply ZA plus ZB by 2, right. Okay. So, this is the case which I have brought to explain. I hope by now you have understood that discriminant analysis, there are few things to understand, that it helps you to predict whether a new member will fall into which group. Will he fall into the passing group or the failing group? Will he get into so whatever, right. So, it helps you to basically predict what is the next outcome, whether by looking at certain continuous independent variables. Okay. Now, this is a case which I have brought as an example from the net I have brought. So, the data examined consists of 5 measurements on each of 32 skulls. Before that let me although we will do this, maybe in the coming session I will also explain this same, I will continue with this. So, what happens is, as I said, discriminant analysis helps you to predict, right, but there is also something like you have to validate the discriminant analysis. Now, how do you validate the discriminant analysis? To validate the discriminant analysis, what you do is the simplest mechanism is very simple, is that whatever your sample is, right, your data set whatever you have, you divide this data set into 2 parts, right. One you use it for the study, the other you use it as a holdout sample, we say holdout group. Now, what is this holdout group? Now, after when you, that means let us say, suppose this is my let us say this is my entire, let us say this is my entire data set. So, I am just dividing the data set into 2 parts, part A and part B. This is my holdout sample, right. Whatever I will do, I will do the test on this data, right, and then I will again run the same analysis on this data and I will compare the results. If the results are coming more or less the same, then I would say my results are validated, right. So, this is a very simple mechanism to do it, there is nothing science in that, too much of science in that, you just had to break the data into 2 parts, that is all, right. So, what I will do is I will explain you how to conduct discriminant analysis through with the help of SPSS also, right, and how to interpret the results of a discriminant analysis. I hope at this moment the theory is very clear and you have understood why discriminant analysis, or for example logistics also, as I have said, both can be used for the same purpose, only difference being that discriminant analysis is little more sensitive to the data assumptions of normality and all, logistic is more robust, but the point is logistics generally works with only 2 categories of variables, whereas discriminant validity analysis can work with more than 2 categories of variables, up to 4, even 4, 5 also. Okay, 5 is too much, maximum 4. So, what I will do is in the coming session we will get into the discriminant analysis through the help of an example. Okay. Thank you so much for this session.